We've talked about the test if a relation is a function is that for every x value, there is only one y value. In other words, x cannot cheat. So we've looked at this in terms of coordinate pairs of relations, and we've also looked at this in terms of equation of functions. Now we're going to take a look at this information from the graph. And we have what's known as the vertical line test for functions, which states that if you draw a vertical line, any vertical line, through the picture of a function, through its graph, and that line, that vertical line cuts through the graph in more than one point, the graph is not a function of x. Let's take a look at a couple of examples of this. Looking at this first equation here, we don't know if it's a function or not. If we were to draw some vertical lines here, we could see that this graph does not pass the vertical line, because for these vertical lines, we can see that for this particular x value here, and this particular x value, and this one also, at this x value, we have two possible y values, here and here. Because of that, this fails and is not a function. Let's take a look at this example over here. Again, we can draw vertical lines wherever we want, and we can see that this does qualify as a function because for any of these vertical lines that we've drawn in, there's only one y value. So let's take a look at this vertical line. We cross through x here, 1, 2, 3, 4. When x is 4, there's only one possible y value, 0. Y is 0. We have nothing up here or down here. So this passes and is a function. Now looking at this graph here, looks like an ellipse on its side. We draw through our vertical lines and see that this fails the vertical line test. When we look here and here at this value, when x is 1, 2, 3, 4, again x is 4, we can see that it has two possible y values. One up here, 1, 2, 3, about 4.5, and then we have another possible y value down here in negative territory, 1, 2, 3, 4, 5, 6, about 7.5. So at these two y values that are different y values, because they correspond to the same x, this fails and is not a function. Last example here. This is what's known as a step function. It looks like steps on a stairs. And in terms of our vertical line test, we can see that it passes. So this would be a function. I kind of gave it away initially when I said it was a step function, but the graph does prove that. When we draw a vertical line, even when we draw it at these 2 points here, while it, on first inspection, you might think, well, it fails because it does go through 2 values. If we look carefully, we can see that when x is 0, the y value is only 2 here. This value of y being 1 is not included in our graph because it is an open circle. We have the same situation here when x is 2. It looks like 2 potential y values, but on closer inspection, we see that the y for x is 2 is only 3, and this value of y is 2 is not included because it is an open circle. Let's take a look at other kinds of information that we can get from our graphs. Open dot. When our graph has an open dot, or a closed dot for that matter, it says that the graph does not go beyond this point. So with open and closed dots, our graph has specific beginning and possibly ending points or both. Does not go on forever. Open dot says the graph does not go beyond this point, and this point does not belong to the graph. A closed dot here says that the graph does not extend beyond this point, and this point does belong to the graph, kind of like open and close brackets when we did our interval notation on solving polynomial inequalities and rational inequalities. The same idea. The open dot would correspond to our parentheses and the closed dot our bracket. Now an arrow on our graph, that says that our graph does not stop. It goes on indefinitely in the direction the arrow points. It might look to us like the graph stops because the paper or the board is limited, but in reality, it would go on forever. So let's take a look at this particular example and see what kind of information about our function we can determine from our graph. First question here is, does this graph represent a function? If we were to draw our vertical lines, we would see that it does pass the vertical line test, and yes, this would represent a function. Now, we're being asked to find f of 4. Remember functional notation f of x. In this case, we're replacing our x value with the number 4. So this 4 in here takes the place of this x. So to find f of 4, we look where x is 4, and this is not labeled, so let's do that now. When x is 4, 1, 2, 3, 4, we're at this point here. So the y value in x is 4 is 0. So in other words, f of x is 0 or y is 0. Next example, next question, find f of 1. Again, remember functional notation, f, usually it's x. So f of 1 says, look for where x is 1. So coming here, here's x is 1. Well, x is 1 on the x-axis. We have no activity in regards to our graph. So we have to travel from the x-axis to where our graph, where our function is on our coordinate plane. In this case, we have to go down here, and there is our point when x is 1. When x is 1, y is -3. So at this point here, we have 1, -3. So our y is equal to -3. Now, we can also look at this information from the perspective of, we don't know x, we want to find x. For what value of x is f of x -4? F of x is another fancy way of saying y. So what we're being told here is that y is -4 and we want its x partner. In this case, since the given information is y, we go to our y-axis. We go to where y is -4. 1, 2, 3, 4. That's down here. On the y-axis, similar to before, there is no graph here. So we have to travel to where our graph is, and that is here. At this point here, our y is -4. And when we go up to our x-axis, we see x is 2. So y is -4. There's our graph. Going up to the x-axis, x is 2. So x would be equal to 2 when y is -4.